Great. Yeah, 720 pixels. Actually, the database and cloud, they are a very famous technology that we are facing and we are utilizing and we are going through whatever, whomever we are, developers or users, consumers. They represent a sort of data source, let's say, stores and a mechanism via which we reach those data stores. The databases, they are actually the data store engine, and the cloud computing, it is the context of securing or delivering those resources to us as end users or as developers as well. We are going to see the basic technology, then after we are going to face the issues and security versus each. Remember that since we are dealing with the remote access, we are in face of a cyber context. So we are not going to define the database as per the database. We are not going to define the cloud architecture or the cloud computing as per the cloud computing itself. No, but to face the issues, to define the issues, to define the problematic view versus the databases, and the problematic view versus the cloud computing, where security has to be put to raise up those issues and to secure them somehow. Databases, as per definition, they are data stores where we store data in background. We are not going to deal, even in local machines, if we have an engine as a database engine, it will give us interfaces via which we manage or we manipulate data. We not manipulate the engine itself, given as per an example, the SQL Server, the Microsoft product. We use APIs like the SSDT, SSMS, or Visual Studio to get connected to a database inside the SQL Server, and we manipulate the data. So databases, they are sort of data stored somehow inside a database management system, DBMS. There are actually inside those databases, at each database in single, there are objects inside that they have to have relations in between each other in order to deliver a service or a product to an end user. Means a database is not a sort of just a bulk of data stored and that's it. No, there are objects. Remember, those objects, they have to have relations between each other to accomplish the delivery of a service or a product to an end user. Other than that, there will be an issue. Delivery of services will not be accomplished well, or there will be a shortage of delivery of services. Some products will not be available, or some items will not be available all the time, things like that. To solve such issue, relations between the objects inside the same database has to be there in order to deliver a final product or a final source, a final service. Given an example, registering courses during the add and drop period using the ADWay in our system, in our college. So there have to be lists of courses displayed. There have to be a user session identified and given access to see those courses. There have to be a validation process, submission of the selected courses. Those are different tasks, and each has to identify either whether the user or the courses or the time, college, all they are stored inside a database, the same database. And there have to be a relationship between each other. Databases, they might have, in so many cases, not some cases, not sometimes only, but in so many cases that it might store very sensitive data. Given the example of a bank, credit cards, financial transactions between banks, medical reports submitted from a hospital to another or a branch to another, something like that. Medical, let's say, surgery results, something like that. Those are cases of sensitive data and they have to be stored inside a database in order to be manipulated in future times. All the databases, they are to be interrogated, queried using a query language only. All of them, all the databases, no exception. No exception. All the database without exception. Any example I give you in future, or any example you find it, there is only a unique, let's say, querying language that can reach to access objects and use objects or manipulate objects inside the database, which is the SQL, structured query language. An example via which we access a database. Database, as we can see in this graph here, in this diagram here, is at the back end. And those are the interfaces. Those are two interfaces here, via which users can access the resources, the database, through some layers. Without discussing those, what are those layers here? There are actually segregation of tasks to do in order to reach the database content. Also, there are specific utilities, there are specific tools responsible for dealing with a specific type of databases. Given the example of the Visual Studio, it has lists of controls. The Visual Studio, it has lists of controls dedicated to get binded, get connected to a data store in order to retrieve data, like the grid view or any control, a button, a label, a hyperlink, a text box. All they have the capability to get connected to a data store and retrieve data in different ways. Connected mode, disconnected mode. What you have to understand through this graph is that resources are the final point. Interfaces via which we access those resources, they are the front view to an user, whomever is the user, developer or utilizer, consumer. In between, there are segregation of tasks, roles, in order to, let's say, give correct services to correct users. These for the first purpose. The second purpose is to control well the right of access or of accessing resources. This actually graph reminds you with the access control we saw unit number 4 when we talked about the access control, central control, which is done by the administrator after the authentication. It happens here within those layers here. We said that the databases, they are actually a group of data segregated into objects. Each one database has objects in plural. One database has many objects. It might have one object, but one object is useless. It is not needed to be stored inside a database. It is actually, if we just need one table only inside the database, for example, it is better to use it as a static one to avoid time consuming and let's say uh, even resources consuming the database allocation and the space allocation. Thus, one database has many objects. As first view, objects are tables. As first view, objects are tables. Good, but they are not the unique objects we may find or may face inside a database. We might find views, stored procedures, schemas, whatever. Objects, they have to have relations between each other in order to finalize the delivery of a service. What does this mean? It means that, for example, registration of courses, you as a student, once you are in the registration period, you'd like to choose a course or a list of courses to register and to start your studies upcoming semester. That's good. To do so, you have to access the system, so you have to be authenticated. You as a user. You as a user means username and password. First step. Second step, you have to display the list of courses offered by the College of Economics, Management and Information Systems, from which you have to choose the appropriate courses. Then, after choosing, you have to submit the list of the selected courses. You get the list of courses from which you select and you submit the list of the selected courses. Then after an approval would happen and you get the timetable. Username and password. It is stored in an object. Your username, or all the students' usernames and all the students' passwords are stored in the object number 1. For example, the list of the courses belonging to the College of Economics, Management and Information Systems are stored in an object number 2. Selected courses by the student number 1 and selected courses by student number 2 and selected courses by student number 3 and so on are stored in an object number 3. Timetable of student number 1, timetable of student number 2, timetable of student number 3, timetable of student number 4, and so on. Timetables are stored in object number 4. And so on. Those are example of objects. So student usernames, student list of courses by college, selected courses by student, timetables. They are different objects. The system, once you access using your username, you as a student from College of Economics, Management and Information Systems, college, you not see the courses from the pharmacy college. How it happens? The system, how he knows that you are a student from the College of Economics, Management and Information Systems, not from the pharmacy college. It is due to what? To the relational design. So this way, actually, you make the system understand well and deliver a service, which is, in this example here, the registration of courses in a proper way, without any error, without failure. Due to what? To the relational design. Any questions, please?
No.
Great. So at the end of the day, so relational database, they are designed one relational database. It's a context of interrelating multiple. In this example, he's saying tables, but objects in general. Objects, they are interrelated in order to deliver group of services or one service or whatever. They are interrelated not to make a design and that's it. No, but to deliver a service, to deliver a coherent service. Ala, you need something, Ala?
No مستر بالغلط هذه قلتها.
No worries. No worries. An example, this is one database that has 5 entities. Regardless, you do not have to see that those entities, they are tables or views, or let's say stored procedures or anything else. No. They are entities, objects, interrelated. That's it. This is the first view from which you deduct this is a relational database. It is not a file-based database or anything else. Relation database, actually, it is a context via which we deduct, not we deduct, but it is a field via which we have to recognize list of terminologies. But you have to understand it clearly, and you have to have their definition clearly in your head. Relational database means there are relations between entities, relations between tables, relations between objects. Each entity, say in a table, has to have records or rows or tuples. Given an example, student profiles. The table students has the profiles of students. What does it mean? Means each record or each row or each tuple, it is a student profile. It is a one student profile. Student ID, student name, student last name, student email, student contact, student major, student grade, student mark, and so on. All of those, one record, represent one student profile. A record, row, tuple. An attribute or a column, it represents a value. The list of the IDs, the list of the emails, the list of the names, student names in plural, they are representing an attribute or a field or a column. To design a relation, one relation in between two entities, one relation in between two entities, there have to be two pillars available and actors in this relation: the primary and the foreign, the primary and the foreign key, which are interrelated. Those two components, they are related to each other. The primary key is connected to the foreign key, and the foreign key is connected to the primary key. It's one link. We come back to the graph here to make, for example, those two entities, entity number one, the caller ID table, and the entity number two, the primary table, interrelated. There have to be a primary key, foreign key available. One of them holds the primary key, and the other one holds the foreign key. There is a context via which we decide which one would have the primary and which one would have the foreign key. But there have to be a primary key. Actually, you have to know this context. You have to have it. Uh, you have to have learned it through the database course, INFS307W12C1, I believe. Good. So primary key, it is one indicator to say that this is a unique value that identifies an object. And this unique value that identifies an object, like the ID, for example, or the mobile number, or an email, it cannot be repeated, it cannot be duplicated. No one will have your ID. No one will have your ID within the organization, within the same system. Or no one will have your mobile number within the country. No one will have your email worldwide. It's unique. No one will have another copy from yours. So this is a primary key. This can play the role of a primary key. This primary key, if it is linked to another object, it would be actually generated there, that new object, and it is a foreign key. Foreign. It is foreign. It is not originary to with that new object. No. It is a link from the originary object to represent this object. So thus it is a foreign value. It is a foreign key. Your ID, to represent your ID in the timetables object as a student. So your ID in the timetables table is a foreign key, but your ID in the students table is a primary key. Sometimes we do not need to display a full table in the final view. For example, we would like to display the student profile, but we do not need to display the marks and the history of registered courses. Only the name, the ID, the contact, and the major. Enough. Not all the data to be displayed. Ahmed Al-Jabri. Okay, inshallah. 10 minutes I'll finish. Okay, Ahmed. So this way, would like to display only specific values. So thus, we generate a view that holds a result of a query. And this query would pass actually any interrogation to the database. So the view, it is a result of a query that displays a list of values retrieved based on a specific request from a table, or even more than one table. So a query would have its result displayed through a view or a virtual table. Any questions, please? Okay, an example. If you have any questions, you may raise anytime. Examples of entities, whatever, just to pass. Examples of queries. This is actually, since we are seeing create table, create view, this is a DDL. This is actually a sort of data definition language. Since we are just generating and creating objects, we are dealing with a DDL, data definition language. If we would have a select or an insert or an update, they are sort of DML, data manipulation language. But all of them, they are SQL. DDL or DML, they are all SQL. And they are the unique tools used to interrogate or manipulate database list of objects. Okay, at this level, we reach to recognize a secure environment, or let's say the capabilities, the high capability via which we draw, let's say, basic secure database. What is the constraint via which we have to worry once designing a database? Is the injection, the SQL injection only. Database, it is a list of, it is a group of data stored in background, so nobody will touch. Nobody will touch, even you cannot see, you as a developer, because they are in background, they are not in your view. But there are inputs via which you pass your DDL or your DML, the create queries or the insert, update, and delete queries. Those input points, they are to pass queries to the database engine. And the database engine has to execute those queries to retrieve or manipulate the data. What is the problem here? The problem is that attackers or hackers, crackers, whomever concerned, might pass malicious DDL or DML in order to retrieve, or let's say hijack or whatever, in order to use the data from the background, from the database, in an unauthorized manner, non-authorized manner. This is an injection. For example, I'd like to open the account of an administrator. I am not an administrator, I'm an instructor. If I'd like to open an administrator's account, so I'm doing an injection. However the methodology is, there are types, but whether to retrieve the data which is not allowed to be displayed to me, or to stop serves from running, or just to modify the data and falsify it. Those are types of purposes behind of doing the injection, modifying the data only, or let's say blocking, not blocking, but let's say retrieving the data for my purpose, retrieving the data to display. For example, I want to know my colleague, how much he got. Student number one, he wants to know student number two, how much he got. It is a spying context. So you retrieve the data while you are not allowed to see it. So this is the second purpose behind of the injection. Or to block serves from being running. DOS, you know what is the DOS, denial of service. All of them, those three, they are examples of why we do, or why attackers might do the injection, to retrieve the data, to modify it, or to block. And a graph actually via which we might draw an injection, how it would happen. This is the final purpose. Here, see this database house here, or data warehouse here. Here, the data resides. All of the others, they are tools to retrieve or not to retrieve the data. See the green line, It starts from here. This is the user. This is the script kiddie, for example, script kiddie. You know what does mean script kiddie? Use other scripts in order to infiltrate and to reach resources. It starts from here through a public network, a router that gives access to the local network, firewall, for example, layer number one, switch, to deviate, go through this server, a web server here, first number, then after an application server, then after a database server, then after the database warehouse, the database engine itself. See the green line. This is the path that might be followed to reach the data. Okay, the problem is that here the traffic is that it can be actually manipulated somehow, because it's not unique. We can reach this public through this public network, we can reach the company, yes, the open network, but I can go straight forward from here. No need to go through this one. I can go through this server here, not needed the others. There are decisions to happen here. Those decisions, they are the chance of this script kiddie here to test in order to pass from a level to another, because this web application will not give an access to this script kiddie if he did not pass the level of the web servers. If he was not authenticated here, he will not be given access to the application. And a party which did not pass the application server did not get authenticated, for example, would not be given access to the database server, whether this one or this one. And if the database server did not give access to the data store, the query will not reach the database engine itself. Can you repeat what I just said right now, please? At the end of the day, the database is something in the very deep background, and there are layers before reaching to submit the query or to retrieve the data. There are layers that an end user, whomever, a hacker or a cracker, ethical or non-ethical doer, has to pass through in order to reach the data. And here only, the injection happens. So knowing this path, recognition will succeed, might have actually a higher potential to succeed. Very simple example of, let's say, actually an SQL injection, SQL injection, which is actually said the tautology here. I may give it the name tautology, but we see the clear example of the tautology. Select given specific field from an entity where condition constraint here. The field searched vaults specific value. In this example, if the user types, he uses a prompt here, whatever he types here, in this example actually, because we're going to select for the username, or for the F name, for first name, if he vaults this value, we have a constraint now. The result actually will be displayed to me. The query will retrieve the data, which is the F name only. Yeah, okay. We see the example if we do not use strictly like this, and we see how to pass. This is another query that would fail and drop a full entity from the database. Let's pass to the example in clear in order to remind you. Exactly, I'm going to explain this tautology in background. Yeah, great. So we are going to select data from an entity where the value actually has to match a specific, actually, let's say, constraint. We have a clause, and the clause is asking that the name has to be similar to a submitted value, and the password also, this is a field, has to be similar to a submitted value. Great. The name has to be equal to this value here, and the PWD has to be equal to this value here in between single quotations. Okay, the user in the field has to type, for example, username Murat, and the password also Murat, for example. If they are correct, the system will pass. Wrong, it will tell you no, error. But see, if I type the following in the field username, do not type name. No, we type the following: single quotation, space, or space, 1 equal 1, space, minus, minus, hyphen, hyphen. What does it mean? This way, the system will immediately close this quotation here. And we'll see, oh, 1 equal to 1, 1 equal to 1 is usually true. Then hyphen, 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 hyphen means all what comes after is a command. And since 1 is equal 1 true, so he will open the system. Injection successful. In this example, the injection is successful. I'll stop the recording and I'll take the attendance. If you have any questions, meanwhile, you can ask, please.